Hey guys, I just wanted to do a quick video that looks at finding volume of the rectangular prism. I'm going to take a little bit more time than it probably needs because I really want to emphasize a specific formula that we're going to look at. Anytime you're looking at volume, anytime we're looking at volume, we are looking at following a basic formula of area of my base shape times my height. Now, one thing I want to say about that height mentality is we can recognize that a cylinder can be placed on its side, and I talked about that in the last video. If it's placed up and down, we call it a height. If it's placed sideways, like laying down, we call it a length. So that height and length can be interchanged as my variable. We also talked about area for the base shape. I just want to emphasize that. Whenever we were naming things, we named things based on their base shape. So if it was a triangle as their base shape, we called it a triangular prism. If it was a trapezoid, we called it a trapezoidal prism. Prism basically meant that it was connected, those base shapes were connected with rectangles. Okay, so that's kind of our key. Now the unique thing about rectangles or a rectangular prism is, well, it's rectangles connected to other rectangles. So how you look at it depends on what you want to call the base shape. So in this first circumstance, because I picked the formula volume equals area of the base times height, I'm going to look at this as the base of this shape. So if I was going to say this to me would be the base of the shape. So if you imagine that I did a triangle or did a base, this red platform would be my base of that shape. And an area of the base shape, I could solve that simply by looking at volume is equal to, well, I find area by going length times width. So in this case, it'd be 4 centimeters times 6 centimeters. And then I would take those those numbers and I'd times that by the height. And in this case, our height was 2 centimeters high. So doing my calculations, I'm just going to do order of operations. 4 times 6, 24 centimeters squared. And I'm taking that and I'm multiplying it by 2 centimeters. And I get a volume of 48 centimeters. And we have a new unit, a cubic unit, which we call volume. Centimeters squared times a centimeter gives us 3 groups, a cubic unit. So all of a sudden we're bringing that 3-dimensional component out if we're looking at the graph paper component for area. Volume gives that 3rd dimension. So 48 centimeters cubed. Now, I want to look at things from one other perspective. I'm going to try and draw the same shape. So looking at this, I had a rectangle. This was my front face. It then went back. And I want to look at this slightly different. This time, same measurements. This was 4 centimeters. This was 2 centimeters. And the top guy was 6 centimeters. So I want to look at this the same way, only this time we talked about that volume and height being interchangeable. So this is area of my base, and I can multiply it by this time by a length. So in my circumstance, when I'm looking at this, my length is going to be that guy right there. So that's going to be my length. That means that this front face is going to be my base area. So I can look at this and it'll still work exactly what I'm doing. Everything is going to be exactly the same. Volume is equal to the area of my base. Again, we said this time it was 2 centimeters by 4 centimeters. And my length we said was 6 centimeters. So I'm just going to substitute all those variables in. And all I'm doing is I'm going 2 centimeters times 4 centimeters is 8 centimeters squared. And I'm going to take that 8 centimeters squared and times it by 6 centimeters. Okay? 8 times 6, easy enough calculation. It's going to be 48 centimeters cubed. Okay? So again, you'll notice I got the exact same answer, but I did it a slightly different way. And that is really important to kind of have that basic understanding. Rectangles is one of the few shapes that we can really do that with, because everything else will have a different base shape. It's named based on something other than a rectangle. So in this circumstance, I was able to look at this as whether I did the green face as my front or whether I did my red as my base, I guess my area of my base, would decide on kind of how that's going to work in terms of getting volume. So recognizing that as interchangeable is pretty important because there's a few different questions coming up that we're going to work on, and we're going to look at looking at how that solves. I really, really, really want you guys to be using this basic formula and practicing it, because you will see in the next couple days we're going to build on this concept, and we're going to be changing from that volume equals area of base into solving for other variables with triangular prisms and cylinders as well. Okay, I hope that makes sense. Short and sweet, pretty easy, I hope.